Hi, I'm Nirupama along with my project partner Onsh, and today we are going to talk about our project on plagiarism detection. In the next few minutes, we are going to touch upon the points in the slide for our project. Let's talk about basic project requirements. We were required to develop an interactive tool for two types of users to detect plagiarism in student submissions. The software should also segregate plagiarism cases on the basis of severity as well as provide evidence of the same. How much system functionality we have achieved so far in our application? We have developed our application for an administrator and a professor or TA. Once an administrator adds a professor or a TA, professor or a TA can log into the application. We are not letting students or instructors upload submission files to our application. We have integrated our project with Git and we are directly getting homework submission files from there. We have implemented a few plagiarism detection algorithms in our application, such as abstract syntax tree algorithm, LCS, added distance, weighted polynomial function, and mouse trained strategy. We have also segregated plagiarism cases on the basis of severity levels. There are 3 severity levels in our application: low, medium, and high, and these are configurable in the system. We have also provided evidence of each plagiarism case by highlighting the common content in each plagiarism case files. We are also letting professor or TA download plagiarism case report as a PDF file. We are implementing plagiarism detection in scenarios such as variable name change, function swapping, code refactoring, and files having the same author name, possibly an exact match. Let's talk about a scenario for variable name change. Here we have 2 files with different names but similar program structure. In one file we have nums as variable name and in second file we have a as variable name. Let's see how our application is detecting plagiarism in this particular case. As you can see, this is a case of high severity with 99.34% plagiarism, and the common content in 2 plagiarized files is shown here. As you can see from our logged in tickets in Jira, we have completed all the functionalities such as login, various comparison strategies, highlighting common content, and reporting plagiarism results. We have followed the steps in the given slide to ensure code quality. We have 68 unit tests and we have achieved 85.9% code coverage. We have also focused on pulling logic out of controllers into services and make them testable. We have also kept a track of bugs, security vulnerabilities, and suggestions from SonarLint. As you can see here, we have 0 bugs and vulnerabilities, and we have very less code smells and duplications in our project. How did we improve our performance and code quality over time? We have tried to write more unit tests and we tried to reduce cognitive complexity of methods. We have also used better error handling techniques and we used async log4j, which logs not only to a file but also sends emails to team members when some error or exception occurs in application. We have maintained good client-developer communication and we have incorporated feedback from TAs in our application. This is a graph which shows our progress in improving code quality over time. We have eliminated bugs and vulnerabilities completely and we have tried to reduce code smells.
Hi, this is Aunsh, and I would like to walk you through our team's process of development. Along the lines of Agile, our development process was divided into 3 sprints. We had a list of requirements that we placed in our backlog, and we pulled in issues according to their priority. We held a number of face-to-face meetings to discuss obstacles and also important design decisions. We demarcated issues into tasks, stories, and epics. At the end of each sprint, we had a good feedback session through sprint review with our TAs, and we were able to take any issues or any positive feedback forward. Next, discussing task division and focus. In Sprint 1, the major highlight was being able to set up the foundation of the development environment. We were able to implement a sophisticated comparison strategy using the ASTs generated from the Antler library. This provided us a big impetus moving forward towards other comparison strategies. In Sprint 2, we implemented the strategy design pattern, which gave the instructors the opportunity to choose strategies on demand to calculate plagiarism. We also integrated the JGit API, thanks to which we were able to pull in student submissions files directly from Git. In Sprint 3, the major highlight was that we actually were able to implement the MOS training algorithm, where we trained weights and we assigned those weights to different comparison strategies using the weighted polynomial strategy. We also were able to highlight common code in plagiarism cases after reporting the plagiarism percentages on the user interface. We worked towards automating the development process and setting up the environment. We integrated Jira with GitHub with smart commits, linking tickets with GitHub commits. On any pull request submissions, Jenkins builds would run and tests would run along with them. Jenkins would also inform the team of any build failure via email, and we also automated GitHub to inform the team of any PRs created. We followed these steps to push code to master. We pushed completed code from the local branch to remote branch. We created a pull request where at least one approval and all 3 checks would have to pass to be able to merge the branch into master. Here we can see the branch's pull requests as well as a Jenkins build on master on our Jenkins portal. Teamwork has been very instrumental towards the success of our project. Being a team of 3, it was very important that we communicated effectively. We made sure that any sort of tasks that we created were divided equally on Jira. We also try to communicate and make sure that we try to solve each other's problems through pair programming. We faced a number of challenges as a team. We had an issue with the project structure while trying to configure SonarQube. Since none of us had prior knowledge with front-end technologies like Angular or React, we tried to work around them by using JSPs. We did not have much of an understanding of the Antler jar, but we worked around it by understanding it together, and we created and implemented a strong comparison strategy using abstract syntax trees. It was also a challenge adapting to the practice of test-driven development, and we worked towards it by thinking of how to test a function instead of really creating one first. We really feel the system is in shape to be handed over to the client solely because all client requirements have been completed. We have rigorously tested the system. All the bugs that were discovered by testers were triaged and assigned to developers and fixed extremely systematically. We validated the detection of plagiarism and the accuracy against 6 sets of tests where we portrayed different scenarios. And we've ensured that the system is user-friendly and easily navigable from one screen to the other. Talking about future scope, I really believe that we could configure course accounts for this application. An instructor or a TA could be able to also view previous reports or records of plagiarism runs. An instructor could be provided the ability to approve or dismiss a plagiarism case, and a professor could also be given the ability to escalate a report of a plagiarism case to OSCAR via email integration. Another plus point would be that we could enable severity ranges of plagiarism to be configured by the professor himself. That's it from our team. Thank you so much for watching.